So make sure you ask if you're not sure. You are not being at, the questions aren't, can you evaluate functions? Okay, that was way before. So you should absolutely be using the calculator to evaluate functions. And if you're going to use the calculator to evaluate functions, you should 100% be putting it into y equals with the variable and then go into the table. Whether you're using Desmos or the graphing calculator, doesn't matter, to be pulling those off. Okay, and that's what I was talking about with the table set yesterday. Okay, so you should be doing that because you don't want to make a mistake. That's not what you're being quizzed about, right? You're being quizzed about like what's going on. So you want those right, and so you should 100% be letting the calculator do all the work. Type it in once into y equals, and then like go to the table and do what you need to on the table. All right, so that's what I'm going to start with. So the last example here, and this is on page, whatever that one, it's not down there, 218. Okay, a lot of this should be review. And so I just want to look at, before we start looking at it, I'm just looking at these two graphs. And there was a term that we had way before called extrema. What is extrema?
Like the hills and stuff, right?
Yeah, so like basically the hills and valleys. Okay, so we called them minimums and maximums, but we had another term that went in front of them. One was absolute minimums and maximums, and the other one was relative. So what's the difference between absolute and relative?
Relative is like an estimate, and then
absolute is where it is, like if we're looking at a maxima, it's going to be the highest point on the line on the graph.
Okay, no matter what.
No matter what.
Okay.
And the relative is just what you can see.
Okay, so you're right on the absolute. The relative is a little bit different than that. So absolute is like there is nothing higher on this, like if we're talking about absolute maximum, there's nothing higher on this graph. Or if we're talking about absolute minimum, there's nothing lower on this graph. So let's, before we go on, does this first one have an absolute maximum?
No.
No, why not? Because it keeps going, right? We got arrows shooting up. Okay, so there's no absolute maximum here. Is there an absolute minimum on this one? Okay, now, so I'm going to ask you where it is, and then you should say an x value. So where is the absolute minimum?
1.5.
Yeah, it looks like pretty close to 1.5, right? And what is the absolute minimum is the y value?
Negative 2.5.
Yeah, like negative 2.5. Is that okay? So where is x values? What is y values? Is that okay? So no absolute maximum, absolute minimum right here. On this other one, is there an absolute minimum?
No.
No. Is there an absolute maximum?
No.
Okay, is that okay with everyone for absolute? All right, so then whoever it was said the relatives are the hills and valleys, right? Okay, so how many relative maximums are here? 1. Is that okay? Where is it?
Like half, 0.5.
Yeah, I think it's, these are going by halves, so maybe even 0.25.
Oh, okay.
Yeah, and what is it?
2.5.
Is that okay? How many relative minimums are there?
2.
Okay, well, so that's kind of a trick question. So if this is an absolute minimum, we're only going to count this one as the relative. Is that okay? So then there's only one. There's one absolute, but then there's one relative minimum. Okay. So then, where is the relative minimum?
0.75.
Negative 0.75, and what is the relative minimum?
Negative half.
Or negative. So these are going by 1. So yeah, negative half. So is that okay? Is there, or how many relative minimums are on this one?
Just 1.
1, because it's not an absolute, right? Because there's no absolute minimum or maximum on this one. So where is the absolute, where is the relative minimum?
It looks about 0.5 again.
Yeah, kind of like 0.5. What is the relative minimum? And they're going by 2s. -1, is that okay? How many relative maximums are there? 1, where is it? Yeah, real close to -2. What is it? 6, is that okay? Okay, so that's the first part we're talking about. We're talking about also zeros and intercepts. So again, mostly review, and we're just comparing the two. So we're not really saying too much about them. We're just kind of saying these are those and those are these, and maybe we'll compare like the maximums and stuff like that. All right, but it says substitute so they give you G up in the top right, and they say graph F. Okay, and so again, they're doing a table, an XY table. This is where you should be putting this stuff in your graphing calculator and letting the graphing calculator tell you the rest. Now, they already did it. So to finish this table off, at -2, what's the Y value of F there at -2? Yeah, about 6. I'm going to zoom in here. Okay, and then at 0 is what? 0. And then at 2? Yeah, I think you're going by 2, so 10, yeah. Okay. And so then you got this graph, okay? So now we're going to compare the two. Okay, so then which function has the greater relative maximum? Well, we kind of already did this, so which one has the greater relative maximum? So you're comparing Y values here.
Secondly.
What, so F or G?
Oh, F.
F has the greater relative maximum. Is that okay? Right, it says, right, has a relative maximum of about Y equals 6, and G has a relative maximum between 2 and 3, so then yes, F has the greater maximum. Okay, so now we're comparing, I'm going to leave this zoomed in. So now we're comparing zeros and Y-intercepts and end behavior. And so basically you're just listing them out, and then you do your comparing afterwards. So the zeros of F, they got 3 spots. What are the zeros of F?
-3, 0, and 1.
Is that okay with everyone? What about the zeros of G? They got 4 of them. And these are approximations.
-1, -half, 1, and 2.
Is that okay with everyone? Okay, so now we're jumping down. We're still comparing the two. Instead of comparing the zeros, we're comparing intercepts. So we're doing both X and Y intercepts. What's the X intercepts of F? -3, 0, 1, right? They're the same as the zeros, right? Those are interchangeable, basically. Okay, and then they say the y-intercept is 0. So does that make sense for F that the y-intercept is 0? Okay, so what about the x-intercepts of G?
-1, -half, 1, 2.
Again, they're all the same, right? As the zeros, that is. And then does it make sense that the y-intercept is 2? Okay. And so now let's take a look at end behavior, right? This is where we're going super far out to the left or super far out to the right, starting with F. As x approaches -infinity, when we go super far to the left, what is y doing? Going to -infinity. And as we're still on F. As x approaches +infinity, way out to the right, what's y doing? +infinity, yeah. Is that okay? As G, right, no, moving to G. As x goes to -infinity, way out to the left, what's G doing? Positive infinity. As x going way to the right, as x is going to +infinity, what's G doing? positive infinity. Okay, so is this okay? Now what we want to do in the long run here is like, we're looking at graphs and we're looking at the important parts. So the zeros all the intercepts are important. And if you think about, right, math does math, and you can do math just for math, or you can use it to explain situations. And so often, right, these y-intercepts are important because that's usually like when the clock starts, or usually it's where the clock starts. Okay, and so what is your value when you start? Often it's 0, 0, but not always. Okay, so if you think back, like when we were doing those, throwing stuff off a cliff, or up, we weren't throwing it off, but like throwing it up off a cliff, we started higher, right? Because that was still our y-intercept, so it's still important. Okay, we usually start at x-intercepts, things happen there. Okay, end behavior, things happen there, right? Like, so like if you're thinking about like end behavior, if you're thinking of the way populations grow, like populations are either going to do one of like three things, right? They're going to either increase forever, which basically never happens. They're either going to stabilize or they're going to crash, right? So like extinction. And so what's going on? What happens? Like in like right with the pandemic, that's what people were trying to figure out. Okay, like is COVID going to go away, or is it going to go increase forever and ever, right? And so like they model these things with the data and they try to figure it out. So that's an end behavior kind of situation. Okay, so that's why we're looking at these kinds of things. That's what I have for you today. You have the rest of the time to work on 21 to 33 odd, or you can work on the spiral review that's due tomorrow. It doesn't matter to me which one you're doing. Okay, you should be able to get at least one of those done anyway. And then tomorrow, remember, I'm not going to be here, but right, there's a video, and I already made it, and it's not, the next section isn't very hard. We're going to have a quiz over this section that we're finishing today, and then one that we start tomorrow. So make sure you watch that video while we're here, because like, don't run into right, where no one watched the video for that snow day, and then all of a sudden we can't do the quiz. Right, just watch that video, and it's not really a very difficult thing. Okay, so then on Thursday I'll get back and figure out whatever we need to talk about from there, finish off the section, quiz over 4.1 and 4.2 on Friday. Okay? All right, so please ask.